All right, this is our third day of Unit 4. And today, a lot of what we talk about is just going to be review. We're going to review all of our factoring strategies and add two more factoring strategies. So when you're factoring a polynomial, the first thing that you should always think about every single time, no matter what, is there a common factor that these terms in this polynomial have. So for this first little one, we're just going to do a couple examples. We're looking at 7x squared minus 28. Hopefully you notice that both of those have a factor of 7, and we can factor that out, and it would leave x squared in the first term and minus 4. And if we notice these GCFs, it makes it a lot easier because in this case in particular, we would notice that this is a difference of squares and we could continue factoring from there. Right now we're only going to focus on the GCF though. So in this next one, 2x to the third minus 9x squared, you might notice that they have a common factor of x to the second power, and that would leave a 2x minus 9. This third one, 5x squared minus 35x, we both terms have a factor of 5 and both also have an x. And in this case, if we factor out a 5x, it leaves behind an x minus 7. And the next one, 8x to the third power minus 40x squared minus 16x. Lots of big numbers there, or big-ish numbers. And to make sure that you're looking big enough. So they do all have a 2 in common, but we can actually even go up as high as an 8. So this has an 8 in common and an x. And if we factor out that GCF of 8x, we're left with x squared minus 5x minus 2. Last one, even if there's lots and lots and lots of terms, like here's 4 terms, we can still look for a common factor. We have a 3x to the third, a 27x squared, a minus 3x, and a minus 27. Those all have a factor of 3 in common. And when we factor that 3 out, we're left with x to the third plus 9x squared minus x, and then a minus 9. So everything we look at today, pause and think about, does it have a common factor? Okay, we're going to look at some different factoring strategies today, and we're going to think about them in terms of the number of terms they have. So the first ones that we're going to look at are if we have 2 terms. Always, 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 you should check very first to see if there is a common factor. So this expression 98x squared minus 8, you might notice they have a common factor of 2. If we factor out that 2, we have a 49x squared minus 4. And why it helps to do these GCFs first is that then you can look at the expression that is left and decide what it is. You might not have recognized that it was a difference of squares at first, but now that you can see that 49 and that 4, you can see that this is a difference of squares, so we can continue factoring it. 49x squared minus 4 factors as a 7x, and we have a plus 2 and a minus 2. So here's our factorization. Let's try another square pattern. 9x squared plus 121 is equal to 0. So if we factor that, again, we should scan and see if there's a common factor. In this case, there's not a common factor. But we recognize that it's perfect squares. 9 is a perfect square. 121 is a perfect square. So we have a 3x and a 3x at the beginnings. And the 121 is going to give us 11s. But this is a plus, so our pattern is that we need imaginary parts here. So it's 11i, and we have a plus and a minus. If we continue solving, we set each of those factors equal to 0. So we get a negative 11i. And if we divide by 3, we have one of our solutions here. A lot of times you can do those in your head. It's a minus or a plus 11i divided by 3. So that's our review of our sum and difference of squares. Sometimes we also have a sum and difference of cubes. The first one is a difference. So our pattern tells us that a to the third minus b to the third is the same as a minus b times a squared plus ab plus b squared. So our problem here is x to the third minus 343. X to the third is our a cubed, and our b cubed is 343. So a is just x, and b is the thing that we raised to the third power to get 343. So b is 7. So our factorization is going to be x minus 7. Then we're going to square a. We're going to add a and b multiplied together, which is 7x. And we're going to add b to the second power, which is 49. So here is our pattern, our factorization of x to the third minus 343. And again, if I'm going fast, it's because this is review. If you need more help with these patterns, they can be tricky. So come in and talk to me one-on-one. So this next one, 64x to the fourth plus x, you might notice, and you should always check for a common factor. These both have a factor of x, so we can factor that out. Don't lose this term. This is like a 1x, so when we factor out the x, it leaves behind a term of 1 there, a constant 1 at the end. So now we can identify what our a and b are. In this case, a is the thing that I raised to the third power to get 64x to the third, so a is a 4x, and our b here is just 1. 1 to the third is 1. So our factorization. Well, number one, don't forget this x hanging out front. Our pattern is a plus b, a squared minus ab plus b squared. So we have 4x plus 1. Now we need to square the 4x. Don't forget, square the 4 and the x. Subtract a times b. A times b in this case is 4x times 1, which is 4x. And then our last term is b to the second power, which is just 1. So here's our complete factorization. This part of it, remember, when we use our cube pattern, is not factorable. So we can't factor it a little bit more. It's good to check sometimes. All right, now we're going to start looking at things that have 3 terms, trinomials that have 3 terms. So the first type, easy peasy type, you can do these without hardly even trying. We're going to refresh on what happens when there's the dreaded number in front. And then a new type for today, new, super exciting, is called a quadratic type. It's very similar to quadratic, but you might notice that the powers are a little different. So we'll talk about those as well. So first, easy peasy ones. Remember when we have x squared plus something like this, x squared plus 5x minus 36, we think about the factors of this number that add to this number. We have x's in the beginning leading us, and in this case it would be 9 and negative 4. So here is our factorization. The next one down, remember we're always supposed to scan, and I should mention it every time, but I sometimes forget that you should scan and check for a GCF. What do these things have in common? Well, sometimes they don't have anything in common, but this one does. We have a factor of 2x that is in common. We can factor that out to get x squared plus 5x minus 14. And this thing that kind of looked hard to factor at first now looks much easier to factor because that GCF is no longer mixed in and making it look difficult. So our 2x is still hanging out, and we're thinking of factors of negative 14 that add up to 5x plus 7x minus 2. And there we go. So those are our sort of easy peasy ones. These ones are a little bit harder, or a lot bit harder, depending on how you feel about it. So we can't just put, well, number one, we should look for a GCF and just always check for that. We've got a 10, we've got a 6, maybe 2 is going to work, but then you spy that 11 in the middle and you're thinking, shoot, that is not going to work out. So no GCF here. What that means is that you're not just going to have an x and an x here because we need it to give us a 10x squared. So to get that 10x squared, we can maybe use, there's a couple combinations we could use. We could use a 5x and a 2x, or we could use a 10x and a 1x. Let's try out the 5 and the 2. Now that gives us the correct beginning. We'll use this 6 at the end, and the possibilities are 3 and 2 or 1 and 6. So maybe we put a 3 here and a 2 here, and we test it out and see if it works. And here we have a 4. Oh shoot, I guessed right the first time. I try to guess wrong so you can see what happens when you guess wrong, but sometimes I do it the right way. So I have a 4x and a 15x. That can totally add up to negative 11 if I want it to. I need a negative 15 and a positive 4. So the 15 needs to be negative. It's going to be a minus 3. The 4x needs to be positive. It's going to be a plus 2. So that looks kind of messy. I'll rewrite it. 5x plus 2, 2x minus 3. All right, this one below, we'll try one more of these because it's always good to practice. The more you practice these, the better you get at them. We have 12x to the third minus 25x squared plus 12x. You might notice there is a common factor of x. So let's get that out of the mix. And now that we have that factored out, we can focus on the rest. It would have been nice if something had factored out of this 12, but nothing did. So we have a few possibilities there. We could have maybe a 6x and a 2x. We could have a 3x and a 4x, or we could have a 12x and a 1x. One of those combinations. Not sure which. We really literally just have to grab one and check it out. So let's try the 3 and the 4. On the other end, we have a 12. So kind of the same possibilities. Could be a 6 and a 2, a 3 and a 4, a 1 and a 12. Let's try 6 and 2. And let's test and see if it worked. This gives me 8x. This gives me 18x. That's not going to get me to 25. 26, yes, but not 25. Close, but not close enough. And I don't think the signs would have worked out very well either, but maybe they would have. Okay, so the 2 and 6 didn't work, so maybe we try, instead of 2 and 6, maybe we try a 3 and a 4. Oh, that would be kind of weird with a 3 and a 3 and a 4 and a 4. I don't know if that would work. Let's switch it just for funsies. How about we put the 4 here and the 3 here? Well, that would give me a 16x, and this will give me a 9x, and hey, that could be a 25. They both need to be negative, so both negatives here. I'm going to rewrite it just to make it nicer. So it's an x times a 3x minus 4 times a 4x minus 3. And again, I would just test out different combinations here until you come up with the right combination. The more you do it, the more quickly you can do it. You get better at finding combinations fast. Okay, here is our new type for the day. We have 2 new types for today, so this is our first new type. If you have a trinomial, 3 terms, and if the powers look something like this, we can factor it. It's really similar to factoring something like x squared minus 4x minus 12. If we were factoring x squared minus 4x minus 12, we would say, oh, it's factors of negative 12 that add up to negative 4, x minus 6, and x plus 2. Well, our factorization of this thing is very, very similar. Let me move this down a little bit. Give myself a little space. Instead of x's here and here, we're going to use x squared. And we can still think about it kind of the same way. Factors of negative 12 that add up to negative 4 is an x squared minus 6 and an x squared plus 2. The powers are just a little bit different, but the process is the same. And I want to multiply this out for you to show you that it does indeed work. So let's multiply it out. We have in the first here and here, we have x to the fourth. Here's a 2x squared, a negative 6x squared, and a negative 12. And you can, in fact, combine these two, and you end up with an x to the fourth minus 4x squared minus 12. So it totally works just fine. So our factorization is x squared minus 6 times x squared plus 2. I'll get these out of the way so that they aren't blocking it. Oh, everything's coming. Okay, one more similar one. Again, you should always, always, always look for a common factor. In this case, we have a common factor of 2. That leaves x to the fourth plus 7x squared minus 30. So we notice that this is a quadratic type. It's very similar to a quadratic, but those powers are doubled, so we'll use x squareds up here. And we can use the combination positive 10 and negative 3 that multiplies to negative 30 and adds to 7. So there's our factorization. Okay, we're going to solve this for x now. So remember, the fundamental theorem of algebra tells us we're going to have 4 solutions to this equation. So if we factor it, we maybe look for a GCF first, but unfortunately there is no common factor here, or maybe fortunately. Well, if we factor this, this is a quadratic type. It's very similar to a quadratic, but the powers are double. So we're going to have an x squared and an x squared up here. We're thinking of factors of 4 that add up to negative 5. It's going to be a 4 and a 1, and they both need to be negative. And you might notice something about this. We can factor that a little bit more. X squared minus 4 is a difference of squares. It's x plus 2 and x minus 2. That's a really fancy 2. And you might notice something about this. It is a difference of squares. We can factor it as x plus 1 and x minus 1. And so now you can see our 4 solutions, positive and negative 2, positive and negative 1. Fabulous. Okay, our last factoring strategy of the day is a new factoring strategy, and it is called factoring by grouping. This is used when you have, or you can try to use it, when you have 4 terms. So we're going to do a couple of these to get the hang of it. When you're doing factoring by grouping, you break the polynomial into 2 groups. Group number 1, group number 2. And for each group, you think about what its common factor is. Well, 5x to the third and 10x squared have 5x squared in common. And if I factor that out of just these first 2 terms, it leaves me with 10x plus 2. For my second group, if I think about what they have in common, I notice that they have a 3 in common. And if I factor that 3 out, it leaves me with an x plus 2. And the tricky thing with factor by grouping is to notice that these 2 are identical. This is 5x squared times x plus 2. This is 3 times x plus 2. X plus 2 is currently a common factor of these 2 terms, because right now I just have 2 terms, this one and this one. So these 2 terms have a common factor of x plus 2. I can factor that out. If I factor an x plus 2 out of this, what it leaves behind is a 5x squared. And if I factor out an x plus 2 from this thing, what it leaves behind is the plus 3. So here is our complete factorization. X plus 2 times 5x squared plus 3. Sometimes you can do a little more with this, but in this case we cannot. Let's try a couple of those just for funsies. So first group, I look at the first two terms together. These happen to have a 3x to the third in common. If I factor that out, I'm left with an x minus 6. I look at my second group and I notice they have a 4 in common. If I factor that out, I am left with an x in this position and a minus 6. I notice, hey, these two are the same. That's a common factor for those two terms now. We can factor that all the way out of everything. And what that leaves behind in the first slot is a 3x to the third. And over here, I'm left with the plus 4. And I'm done. Let's do that in an equation now. X to the third plus 5x squared minus 4x minus 20. So in the first group, I notice they have an x squared in common. If I factor that out, it leaves an x plus 5. Second group, well, these are negative. I'm going to factor out a negative 4. And that leaves behind in that first position an x. And if I factor a negative 4 from a negative 20, that leaves a plus 5. Now I have a common factor of x plus 5 in both terms. I'm going to factor that all the way up to the front. And what that leaves behind is the x squared and the minus 4. X squared minus 4 is a perfect square. Difference of squares. I can factor it a little bit more. It factors as x plus 2 and x minus 2. So our three solutions are negative 5, negative 2, and positive 2. Pretty good. We were going to have three solutions. We found them all. Okay, this method, factor by grouping, it doesn't always work. There are certain polynomials that it works for, but there are many more that it doesn't work for. So I want you to just see what happens or what it looks like when it doesn't work. So in this case, my first group, if I factor out a common factor of x squared, it leaves an x plus 5. And in my second group, if I factor out a common factor of 5, it leaves x plus 3. So what you should notice here is that the x plus 3 is much different than the x plus 5. They are not the same. If those two things are not the same, there is no common thing I can factor out to the front. It didn't work. I'm done. It failed. Factor by grouping does not work. And right now, you wouldn't have another strategy to try yet. So in the future, we'll talk more about what we might do with this sort of thing if factor by grouping doesn't work. But for now, the ones that I'm giving you are to practice factor by grouping, and they should work just fine. And if they're not working, you probably made a sign error or something. Later, next unit, we will talk more about how to deal with things such as this. But right now, you don't have the tools to factor that. One more just to show you what it looks like when it doesn't work. This factors as an x squared times x minus 4. This factors as a 4 times 5x plus minus 12. And you can see that we don't have a same binomial here. So we are done. The factor by grouping did not work. Okay, last equation. So after you have factored and factored some more, you should always check and see if any of the factors can be factored a little bit more. In other words, like keep going until you literally cannot factor anything else. So we're going to solve this equation for x. It's 4x to the third minus 8x squared is equal to 49x minus 98. When we're dealing with polynomials, remember that we want our equations to be equal to 0. So I'm going to subtract the 49x and add 98. Is equal to 0. And now that we've done that, we notice that we have 4 terms here. Factor by grouping is a strategy that we want to try. So if we look at this group, we can factor out of 4x squared. And that leaves an x minus 2. And from this group, we can factor out a negative 49, actually. And that leaves in this first position an x. And this second term is in positive 98. If we factor out a negative 49, that leaves a minus 2. So we have this x minus 2 and x minus 2 that we can factor to the front. It's a common factor of both of those terms. That leaves a 4x squared minus 49. Hopefully you notice that this is a difference of squares and can be factored a little bit more. It will be a 2x plus 7 and a 2x minus 7. And then, of course, we still have our factor of x minus 2. So our 3 solutions are 2, negative 7 halves, and positive 7 halves. Hooray! And that's it. So most of what we talked about today was a review. The 2 new strategies are factoring a quadratic type where it has 3 terms and is in many ways similar to quadratics we've factored in the past. And we have factor by grouping. Remember, if you need extra help, please come in and talk to me at lunch or after school or before school. And the homework assignment for this unit is the salmon colored, and it is due in the next class period. Thank